Hello students, welcome to a series of additional mathematics programs for grade 10 and grade 11. The topic for today is application of differentiation. We have many different subtopics in application of differentiation, and today we are going to look at equations of tangent and normal. So the lesson of today will be on equations of tangent and normal, where you will learn how to find the equation of tangent and the equation of normal of a given curve at a particular point. So the prior knowledge for today's lesson: first, you need to know how to find the equation of a line. You also need to know how to differentiate any given function. And finally, how to find the gradient at a given point. So we're going to start with a recall of how to find the equation of a line. Let us start with this example. Find the equation of the straight line passing through the points 1, 4 and 3, 8. Do you still remember what we need to do to find the equation of a straight line? First, we need to calculate the gradient. And do you still remember the formula for gradient? Okay, let us see this example. So we have 2 points, 1, 4 and 3, 8. I need to calculate the gradient. So first, I'm going to label the coordinates as x1, y1 and x2, y2 respectively. Now, the formula for gradient is y2 minus y1 over x2 minus x1. So now I'm going to replace the values of x1, x2, y1 and y2 in the formula. 8 minus 4 over 3 minus 1. And simplifying, I will get the gradient as 2. Now, to find the equation of the line, we have two different methods. Let us look at the first method. So here I'm going to use the formula y equal to mx plus c. Remember, m is the gradient and c is the y-intercept. So here the gradient is 2. I will have y equal to 2x plus c. Now I can either substitute the point 1, 4 or the point 3, 8. So here I will replace the x coordinate by 1 and the y coordinate by 4. I will then obtain the value of c as 2. So the equation of the line is y equal to 2x plus 2. Now the second method is using the formula y minus y1 over x minus x1 equal to m. So here I will have y minus 4. I'm again using the same point 1, 4. So y minus 4 over x minus 1 equal to the gradient, which is 2. Cross multiplying and simplifying will give me y equal to 2x plus 2. So you have two ways of finding the equation of a line, and you can choose either y equal to mx plus c or y minus y1 over x minus x1 equal to m. Now we move on to the topic. So look at this picture. Here you have the equation of a curve, any curve, and you have a tangent. What is a tangent? If you will remember, a tangent is a line which touches a curve at a particular point. So here the tangent is touching the curve at the point P. Now, the normal is a line which is perpendicular to the tangent. That is, the normal and the tangent are two perpendicular lines, as you can see in the diagram. You need to remember that perpendicular lines have gradients which when multiplied will give -1. I repeat, perpendicular lines will have gradients which when multiplied will give -1. So here, if the equation of a tangent has gradient m1 and the equation of a normal has gradient m2, so m1 times m2 would be equal to -1. In other words, the gradient of a normal will be equal to -1 over the gradient of a tangent. That is, m2 will be equal to -1 over m1. Let us look at these examples. If the gradient of the tangent is 3, then the gradient of a normal will be -1 over 3. Remember, I just said the gradient of a normal is -1 over the gradient of a tangent. This is one way of looking at it. The second way would be that when you multiply the two gradients, the product should be equal to -1. So, second example, if the gradient of a tangent is -4, then the gradient of a normal will be -1 over 4, which will give me 1/4. Similarly, if the gradient of a tangent is half, then the gradient of a normal will be -1 over half, which is -2. Or, as I have said, when you multiply the two gradients, you should get a product of -1. Last example, if the gradient of a tangent is -1/5, then the gradient of a normal will be -1 over -1/5, which is 5. Now we consider this first example on equation of tangents and normals. Find the equation of the tangent and the equation of the normal to the curve y equal x cubed plus 4x squared minus 5x plus 2 at the point where x equal to 1. Y equal to x cubed plus 4x squared minus 5x plus 2 at the point where x equal to 1. So the first step will be to find dy by dx. That is, you need to differentiate this function. Remember, in the previous lessons, you have learned how to differentiate a given function. So here, dy by dx will be 3x squared plus 8x minus 5. Now I need to find the gradient at x equal to 1. So when x equal to 1, I will first find the coordinates to be able to find the equation of a tangent. So first I need to find the y value. So when x equal to 1, I replace and find y, which is equal to 2. I also find dy by dx, which is equal to 6. So now I know the gradient. Remember, dy by dx gives the value of a gradient. So I know the gradient. I know 1 point, 1, 2, which lies on the line. So I can now find the equation of a tangent, as well as the equation of a normal. So gradient of tangent is 6. I'm going to use y equal to mx plus c. So y equal to 6x plus c. I replace 1, 2, the coordinate 1, 2, to obtain the value of c as -4. So the equation of a tangent is going to be y equal to 6x minus 4. This is the equation of the tangent. Now for equation of normal. If the gradient of a tangent is 6, this means that the gradient of the normal will be minus 1 over 6. So now I need to find the equation of the normal. I'm going to use here y minus y1 over x minus x1 equal to m. So y minus 2 over x minus 1 equal to negative 1 over 6. Cross multiply, simplify, and you obtain the equation of a normal as 6y plus x equal to 13. Second example, find the equation of the tangent and the normal to the curve y equal to 3x squared plus 8x minus 4, given that the gradient of a tangent is negative 4. So here you have already been given the value of the gradient of the tangent. You have not been given the value of x or even the value of y. We will need to find the coordinates here. So y equal to 3x squared plus 8x minus 4. First, I need to find dy by dx, which is equal to 6x plus 8. Now, we know that the gradient of a tangent is negative 4. This means that dy by dx is equal to negative 4. And x will be equal to negative 2. Now that I know the value of x, I can find the value of y. So y will be equal to 24. Gradient of tangent is given as negative 4. Therefore, what will be the gradient of normal? It will be minus 1 over minus 4, which is 1/4. So we know the gradient of tangent. We know the gradient of normal. We have 1 point lying on the lines, minus 2, 24. So we can now find the equation of a tangent and the equation of a normal. So equation of tangent, y equal to mx plus c. Here m is minus 4. So I get y equal to minus 4x plus c. I substitute the point minus 2, 24. I find the value of c, and c is equal to 16. So the equation of a tangent will be y equal to minus 4x plus 16. For equation of normal now, y minus y1 over x minus x1 equal to m. The gradient of a normal is 1/4, and I replace the coordinate minus 2, 24. Simplifying, expanding the brackets, simplifying, I get the equation of a normal as 4y equal to x plus 98. So this part is quite simple. To find the equation of tangent and equation of normal of a given curve at a particular point, you always need to find dy by dx. You replace the value of x to find the value of y if it is not given, and you replace the value of x to obtain the gradient of a tangent. Once you know the gradient of tangent, you can find the gradient of normal. In some questions, you might be given the gradient of a normal, and you have to find the gradient of a tangent. And once you know the gradient of a tangent and the gradient of a normal, you have 1 point lying on these lines. It's very simple to find the equation of tangent and normal because you're simply finding the equation of a straight line. Let us move on to the third example. The equation of a curve is y equal to x squared, square root of 3 plus x, for x greater or equal to negative 3. The first part, you need to find dy by dx. The second part, you need to find the equation of the tangent to the curve at the point where x equal to 1. And the third part, you need to find the coordinates of the turning points of the curve. So here we have the product of two functions. Remember, you have learned how to use the product rule. So I will have u as x squared. So if u is equal to x squared, du by dx will be 2x. V will be equal to square root of 3 plus x, which can also be written as 3 plus x to the power of half. So dv by dx will be half into 3 plus x to the power of minus half times the derivative of the bracket, that is 3 plus x. So you bring down the power, you decrease the power by 1, and you multiply by the derivative of the bracket. When you differentiate the bracket here, it is 1. So the expression for dv by dx will be half into 3 plus x power minus half. Now, dy by dx, if you remember for product rule, the formula is du by dx times v plus dv by dx times u, or simply u dv by dx plus v du by dx. So here I will have u times dv by dx plus v times du by dx. Factorizing, I have taken x and 3 plus x power minus half outside. So inside the brackets, I will be left with half x plus 2 into 3 plus x. Simplifying the square brackets, I obtain x into 3 plus x to the power of minus half into 6 plus 5 over 2x. So this is for the first part, dy by dx. Second part now, we already have the function y, we know what is dy by dx, and I need to find the value of y when x equal to 1, which is equal to 2. And I also need to find the value of dy by dx, which gives me 17 over 4. So now to find the equation of a tangent, here I'm using y minus y1 over x minus x1 equal to m. Replacing the coordinates 1, 2 and using gradient 17 over 4. Cross multiplying, expanding the brackets and simplifying will give me as equation of tangent either 4y equal to 17x minus 9 or y equal to 17 over 4x minus 9 over 4. So this is my answer for the equation of tangent. Now for the last part, I need to find the coordinates of the turning points. So you will remember that turning points will be when dy by dx is equal to 0. dy by dx equal to 0. So I will have, this is dy by dx, the expression for dy by dx equal to 0. So either x will be equal to 0 or 3 plus x to the power of minus half equal to 0 or 6 plus 5 over 2x equal to 0. So here it will be no solution. And here I will obtain x equal to minus 2 decimal 4. Now I need to find the y values. So when x equal to 0, y will be equal to 0. When x equal to negative 2 decimal 4, y will be equal to 4 decimal 46. You can also give your answer as a fraction. So the coordinates of the turning points will be 0, 0, 0, 0, and negative 2.4, 4.46. You now have a few questions to practice. So the first question, find the equation of a tangent and normal to the different curves at given points. So in this question, the coordinates of x and y have already been given. Second question, find the coordinates of the point on the curve at which the tangent is parallel. What do you know about parallel lines? Do you still remember that parallel lines have the same gradient? So here you will need to find dy by dx. And because the tangent is parallel to this line, this means that the gradient will be equal to 5. So you equate the gradient to 5. You find the coordinates. That is, you will find x, then you need to find y. Number 3, find the gradient of the normal to the curve when x equal to 4. Quite simple. Number 4, so you have a curve and you're told that at the point where x equal to 1, the normal has a gradient of 1/3. You need to find the value of k. And using this value of k, you need to find the equation of a tangent when x equal to 2. Number 5, you need to find the equation of a normal. Number 6, the normal to the curve y equal to x minus 2 into 3x plus 1 to the power of 2/3 at the point where x equal to 7/3 meets the y-axis at P, and you need to find the exact coordinates of P. Exact means you either give your answer in fraction or in terms of square root. Last question, the points P and Q are on the curve y equal to x squared. The value of x at P is -2 and the value of x at Q is 3. So you need to find the equation of a tangent at P, equation of normal at Q. Now, the tangent at P meets the x-axis at A and the normal at Q meets the y-axis at B. You need to find the distance AB. Remember, when a line or even a curve meets the x-axis, this means that y is equal to 0. And if a line or a curve meets the y-axis, x is equal to 0. So you need to find the coordinates of A and the coordinates of B, and then find the distance AB. You also have a few links where you will get additional information on how to find the equation of a tangent and the equation of a normal. You will also get additional exercises to practice. So students, in today's lesson, we have learned how to find the equation of a tangent and the equation of a normal. What you need to remember is, first, perpendicular lines have gradients that multiply to give -1. Or in simpler terms, m1 times m2 will be equal to -1, where m1 is the gradient of a tangent and m2 is the gradient of a normal. So you will be given a function y, you will have to differentiate it, find dy by dx. If you're given the coordinates of x, you can find dy by dx and the y value. Then you find the gradient of a tangent, the gradient of a normal, and the equation of tangent and equation of normal. But in some questions, you might be given the gradient of a tangent or the gradient of a normal or a line which is parallel, so you need to be careful. I hope you have understood this part on application of differentiation. I would advise you now to practice questions on finding equation of a tangent or equation of a normal in your book. In the questions given here, as well as in the links that you have been given. So until we meet again, it's goodbye from me. Thank you for your attention.